couple minutes early. So my name's Lisa. I manage NGA's Open Data program. I'm so excited for this session where we're going to highlight the finalists of the MTA Open Data Challenge that we ran last fall. We put out a call for members of the public to explore our open data sets and make something cool with them. And we got over 100 amazing projects. So in this round, we have 5 projects being presented. These are all finalists who are highlighted on a blog post. If you just Google MTA Data and Analytics blog, Open Data Challenge, you can read more about them. But now you get to hear about their projects live. So this is going to be a quick lightning round since we do have so many amazing projects to cover. I'm going to ask you whole questions to the end and find these people during lunch if you want to learn more about the work. So I'm going to pass it to Hannah, who is my colleague who's helping facilitate the session and make sure we stay on time.
All right. So Macaulay team, do you want to come up? I think we're just going to go right into it.
My name is Huda Ayaz. I am a senior at Brooklyn College, and I served as the project manager of our team.
Hi, my name is Olivia Fratangelo, and I'm a senior at John Jay College, and I'm one of the data analysts for our team.
There was also another data analyst on the team.
The three of us are Macaulay students who came together for the Macaulay Honors Datathon last September in collaboration with the MTA, and we worked on looking at some data to solve real-life challenges that people are facing in our city. We were honored to be finalists at the Datathon and also for the MTA Open Data Challenge, and we're excited to share our work with you all. On the next slide. Before jumping into any of the data, we first worked together to come to a research question. According to our research, approximately 10% of New Yorkers require accessibility accommodations, and most New Yorkers make use of public transportation through the MTA. This includes students as well. In fact, students are such a huge chunk of MTA ridership that in September in particular, we usually see a spike in how much use we're seeing of the MTA. But at the same time, the MTA is far from perfect. We often experience delays or technical outages that prevent students from getting to school on time. Considering that nearly 35% of public school students were chronically absent just in the last school year, it becomes even more important for us to make sure that we make it even easier for students to be able to get to school. Next slide. So from here, we were able to come to our research question. Are current accessibility standards at subway stations near specialized high schools adequately supporting students, especially those with disabilities? Next slide. We assessed our question based on criteria defined by MTA data scientists at the Datathon, and we're able to find quantifiable data on outages and disability demographics from the MTA and from the Department of Education in order to address our question. Next slide. We started to address our question based on 3 main questions. First, by seeing what stations are near each of the specialized high schools that we were looking at, then seeing what the accessibility standards are currently at those stations, and then finally to see what each school's need for accessibility is in order to bring this information together and answer our question.
So now moving on to the implementation. You can do it. Yeah, whatever these started. Okay, so first we'll be discussing the implementation of the DOE demographic data. So we were trying to find data on specialized high school students. So we went to the DOE website and found this demographic snapshot. And the demographic snapshot included data on students in DOE elementary, middle, and high schools. So we had to narrow down this data to only what was relevant to our research question. So next slide. So here you can see our entire project was done in Python and Python notebooks on Google Colab, Collaborate. And some of the libraries we used are NumPy, Pandas, Matplotlib, and Scikit-learn. So first we had to clean the data, make sure there were no null values. Sometimes working with government data can be a little bit tricky because it's not specifically clean there, not taking out the null values. So we did that. And then we also narrowed it down to make sure that the categories were relevant. So the rows and columns were only regarding students with disabilities and these specialized high schools. Next slide. So this is the data before. We did data cleaning before we filtered out the rows and columns. And next slide. This is the DOE data after. So please note that there's 9 total specialized high schools in New York, but only 4 of them are included here because that was just what was included in the demographic snapshot. So we'll be working with 4 high schools for the remainder of the analysis. Next slide.
So along with all of this DOE data that we saw, we also wanted to find MTA open data sets that had information about elevator and escalator outages at train stations across New York City. So we were able to find this one data set that had every single train station in New York City. It had all of the escalator and elevator outages from 2015 to 2024 there. And we were able to connect the schools and find, okay, like these are the train stations near these schools that most of the students are using, and these are the outages at these stations at these schools. So these are the stations or the outages that are most affecting the students here. So we want to take all of this data and combine it to see, what is affecting the students most here, and where are the mostly students being affected across borough, across school, all that. Next little. Yeah, so we used multiple data sets together, and we had to combine everything into a clean fashion. So we did a lot of data cleaning to make sure that, like, okay, we're just taking the past 5 years, because the past 5 years has good, decent data. We wanted to clean out all of the stations that were far away from schools and just use the ones that were close to schools, because that's what's relevant to the problem that we identified. And we also just wanted to make sure that we had the correct outages that we were looking at. So there's two classes of outages in these data sets. The first is scheduled outages, where the MTA had planned these outages saying, like, okay, we're going to do maintenance this time, so we're going to take this elevator out of service. And then there's also unscheduled outages, where some issue happened, maybe some problem happened, and then it was unplanned, and they had to take it out of schedule. So having those two, and also just the total outages, we're able to make a lot of plots and analyze how it was throughout the different boroughs, throughout the different stations. Next slide.
So now moving on to our analysis. Next slide. So here you see the analysis of the DOE demographic data. So this is the percentage of students with disabilities at each of the high schools we analyzed from 2019 to 2024. So the only school that saw a consistent level of percentage of students with disabilities and then a slight decrease was Staten Island Tech. You'll also notice later in the MTA data that Staten Island is not included because there are actually there are no train stations actually near Staten Island Tech High School. And so it's just accessibility-wise the most difficult school to get to, and therefore students with disabilities are then discouraged from enrolling in Staten Island Tech because it is so inaccessible. And then the other schools, which were Rock Science, Liquid Tech, and Lingman, we saw there was actually an increase in percentage of students with disabilities enrolled attending these high schools, which is good because it means that these schools are likely making more efforts to be more inclusive and ensure that students with disabilities are able to attend and enroll in these schools. However, what we wanted to look at was our MTA train stations making the same efforts to be inclusive. Right, next slide. Here you can see all of the schools together on one graph just to compare a little better. Next slide.
Great. So once we had all the elevator and escalator outages, we had just a few questions we wanted to answer. We wanted to answer first, how often are these going out of service? How does this differ across boroughs? Maybe a better funded borough like Manhattan versus a poorer funded borough like the Bronx. And then also, how's the performance near the schools as well? Next slide, please. So here we have two graphs. The left is Manhattan, the right is Brooklyn. So two of the better funded boroughs for the MTA. And this has data about the outages that were happening. So the green line is scheduled outages, the orange line is unscheduled outages, and the red is total. You can see that there's always been more unscheduled outages than scheduled outages over the past 5 years, with an average of 2 scheduled and 4 unscheduled per week at each station. But towards the past year or two in 2024, there's been a slight uptick in the number of unscheduled outages. Even if the number of scheduled outages stays the same, even if the maintenance is staying the same, there are more problems happening, and there's more issues that students are running into that they wouldn't be able to, foresee from previous, experiences of past years. Next slide, please. So while we saw that in the two better funded boroughs, here we have data about the Bronx and from Queens, you can see that, Queens in the past 5 years hasn't had too much difference in performance changes, but the Bronx is particularly notable. From 2020 to 2023, the number of scheduled and unscheduled outages at the stations have been pretty similar. But in the past year, there's been a big difference where there has been a dip in the number of scheduled outages, even though the unscheduled outages has been the same. Now, while we don't have enough data to find a definitive reason for why that happens, a big thing that might be the reason is there might be less funding going towards it now. So there's less funding to schedule outages, there's less funding to make sure that the stations are working properly. But, we can't have that, right? If we're having less maintenance in these poor areas, then this is going to continue to have a snowball effect. And over the years, we're going to see this just get worse and worse and worse for the community, like for the people who are using these stations. Next slide, please. We also want to take a look at two specific schools. So Stuyvesant High School, which is located in Manhattan. You can see here the closest station to Stuyvesant High School that most streets are using are Chambers Street. And almost all of this outages at Chambers Street are unscheduled outages, right? Students are not able to predict like, oh, during this time there might be an outage. It's just happening at all these times. And sometimes it goes even as high as 40 outages in the month. So if you might see like a slight graying on the graph, the graying is the summer months when students are off school during summer break. So here in Stuyvesant, it's not super notable, but you're going to see on the next slide that it is a very important thing that we noted that. Next slide, please. So this is Brock Science High School, and the nearest station to Brock Science is Bedford Park Boulevard. What we saw was that during the summer months, we have some number of, like outages, right? But every year for the past 5 years, right after the summer months, when students are going back to school for the first time, there's an increase in the number of unscheduled outages. And this has been consistent over the past 5 years. There's more total outages and there's more unscheduled outages. So let's say a student is coming back to school for the first time, or they're an incoming freshman at this school, right? How are they supposed to understand like, hey, I'm going to be facing these issues. If I am a student who has accessibility issues, I can't plan for this ahead because there's a sudden increase always at the start of the school year. Next slide, please.
We're just going to skip this and go straight to the conclusion because we're running out of time.
So these are some recommendations we made based on the analysis. The really important one is the third one, seeking outside funding to support MTA efforts, because the lack of funding Taseen described can be supplemented by privatized businesses, which should be, of course, funding the education of students to make sure that, because they're the future of NYC, to make sure that they can really contribute to businesses and to their education and their future careers.
We just wanted to close on a quick call to action for the MTA to continue to bolster accessibility efforts, especially those that are preventative. And we hope this information empowers students to be able to leverage the amount of MTA ridership that we take up to advocate for ourselves, for our peers, and for our fellow New Yorkers. Thank you so much.
Hi, everyone. My name is Bianca. I'm going to be talking about my own experience participating in the MTA Open Data Challenge. But first, a little about me on the next slide. Like I said, my name is Bianca. I work as a data analytics consultant. A lot of my projects are about enhancing data visualization and increasing analytics efficiency for my client organizations. And outside of work, I also do a bit of data work. I co-lead eData Plus Women New York City and Asian and Pacific Islander Tableau user groups. So you're going to hear Tableau a couple times. That's a data visualization software that's pretty easy to start using if you don't know about it. And outside of data, I also rock climb and I read. Does anyone rock climb? Okay, great. It will mob it. So next slide, please. There's a lot of data sets that were published on open data. And for the challenge, we just had to use one published by the MTA. And there were a lot. There's subway incidents, customer feedback, accessibility. And the one that really caught my eye was the MTA permanent art catalog beginning. Yeah, I'm not going to read that. And the reason that I chose this is because I always walk by the subway art. I'm pretty sure some of us, when we took the train here, we walked by some art as well. And I never stopped to smell the roses. So I wanted to give the art its own due attention in my own way, utilizing my skills. Next slide, please. And we know what data looks like. Data is rows and columns. It's like letters and numbers. But what I liked about this data set is that every single row is also a place you can physically visit. It's art you can touch. So I picked out a couple of my favorites because it shows how the variety of art in the permanent art collection. So on the top left, we have Wave Ball. That's an example of architecture. So for this station at West 8, New York Aquarium is on the approximate site of an old roller coaster site. It's also by the ocean, the aquarium. So the artist and the architect brought in inspiration from its surroundings to make that. And another one of my favorites that I'm going to bring up is on the middle and on the bottom right, Signal at Broadway Lafayette. So I always walked by this and I never thought it was art. I just saw those metal structures there and I was like, yeah, I'm going to keep walking. And so I really like this project because it gave me the chance to do research about that and really look into it. And so a little of the significance here is the Broadway Lafayette crossroads were really important train routes for the Iroquois. And so that's actually a campfire. The mosaic on the back are smoke signals, and the mosaic figures on top of that are figures that represent members of the Six Nations. So I like that this art was a physical place I could visit. It's something I can manipulate in Tableau, but it also brings in history and culture. Next slide, please. So my submission is a data visualization created and posted on Tableau Public. It's a public data visualization repository. And I focused on just the artworks on display in New York City subway stations. Next slide, please. And before I get into the data visualization, I wanted to talk about the name of it. So I called my visualization the Museum of Transversal Art. I kept having this recurring thought, kind of like a clickbait article, and it went something like, you can visit this art museum for less than $3. And that's true. And I kept thinking, we have so many art museums in New York City. Why isn't this one of them? So I called it the Museum of Transversal Art. Since I had the M, I had the A, just kind of needed to think of a T. And I thought of several different words: transit, transitional, traversal, transcendent. They all really brought in this feeling of movement, of change. And I ultimately went with transversal because of mainly the first point. The definition of a transversal line in geometry is a line that intersects a system of lines, and isn't every subway line just a line intersecting a system of lines? There's a couple of other reasons, and then this also gave me an excuse to make a really cute logo copying the MTA, where the A is an easel on my version on the left there. Thanks. Okay, I'm going to do a little demo of my Tableau visualization since it is hosted online. So first, what we're looking at here is almost kind of like a classic dashboard look, and I also really wanted that subway map on my visualization. And I'm going to do a real demo. So this morning I took the train to Court Square on the E line. So I'm going to click on this E line here and filter my map so that I can see the stops along the E. And there are really small dots where there's a station with no art, and then a larger dot for stations where there is art. And there was a piece of artwork, at least one, at Court Square 23rd Street where I got up this morning. So I clicked on that dot, and that filtered this list here where I can learn more about temple quad reliefs and stream. Then so I'm going to click on that, and it's going to open a new link so I can learn all the information that I just told you a couple slides ago about an art piece. Yeah. I'm going to unclick this. And I made this visualization because I took my time exploring the subway and also the data to find out about the art, and I really want people to do the same. But if you ever need help, like in any subway station, there's an MTA help point to give you some instructions for how to navigate this dashboard. So I provided some sort of contextual information about art in the subway. So some like big numbers about artwork in the subway, how many artists are featured, and what stations feature artwork. I also thought a little bit about what makes the station artistic. So Brooklyn is the most artistic borough if you're going by number of stations that have artwork, but that's just because there's more stations in Brooklyn, right? But if you take a look at that number relative to the total number of stations, the Bronx is actually probably the most artistic because 68% of all stations have art. And the same with the subway lines. So the 2 line has the most stations featuring artwork, 38 out of 49 stations. But it's actually the Q line where most of them, 93% of all the stations, feature art. So the next focus of my visualization is about the materials of transversal art. So for those, a little bit of context, all of the art in the permanent art collection uses the same materials that the subway is made out of. So along in that same vein, I wanted to take something that I found out in the data and use it in my visualization. So I found that over 3/4 of the permanent artworks are mosaic pieces made out of glass and ceramic. So I made my own data mosaic where each little piece here represents a piece of artwork, and it's colored to the material that it's primarily made out of. And so if I were feeling really confident about my geographic ability, I would look at this, I'd hover, oh, here's a glass piece in Queens on the NW lines, and I'd scroll up, find the station, click it, and then find the link and read more about this artwork, and then maybe go visit it in person. And so what I discovered here is that in Manhattan has the most variety of materials, including paint, sound, even lighting elements. And then the most common ones were glass, ceramic, and metal. That's what the subway is mostly made out of. And you want your subways to be durable, and you want your art to be durable as well. And for those of us who can't immediately calculate how many pieces there are, I included bar charts to help people figure out, 60% of all art is made of glass, but in the Bronx, it's 80%. Next, I wanted to take a look at where every piece of artwork was. So there's a number of different kinds of subway stations. And I ordered them here, reusing the mosaic idea from least exposed to the elements and then to most exposed to the elements. So the subway is entirely underground. That's this first type. And it also has the most variety in art materials. And the last is at grade, which is just fully exposed on the ground. And that's 100% glass. And so I noticed that the more exposed the station is to the elements, the higher percentage that the artwork there is made of glass. Some theories about that: they're probably easier to clean, easier to install, easier to maintain. I just wanted to talk a little bit about the results from participating in MTA Open Data Challenge. One was, I'm here today, so obviously I was named as a finalist, and I was also called most comprehensive view of the data. I hope this helped you see why that is. Second, because I posted this online to Tableau Public, they choose a Viz of the Day every day, and I got chosen right after that was announced. And then thank you. There's one more. And the Data Visualization Society runs a competition every year for the Information is Beautiful Awards. You can self-submit your work. So I submitted my work to be considered, and it made the long list. So in April, I'll be waiting to hear if I made the short list. Maybe not. And then they'll announce the winner at some point, and I won't care anymore at that point. So last slide. I'd love to connect. My LinkedIn is on the left, and my Tableau Public, where you can see this visualization, is on the right. But I highly recommend seeing my visualization on a computer. The mobile view is not great. Thank you.
Thank you for having me. My name is Noah Gunther, and my project is lately on the MTA, where I wanted to create a fun website to look at the most recent available ridership data for the subway and the bus in the city. I'm going to start by talking about the graphics and design I made for this site, and then I'll talk a little bit about the data I used and how I used it. And finally, how I used the API available for these data sets to keep the data fresh, and how I eventually created a web app to optimize the API usage. Next slide, please. Okay, so starting with design and graphics. I primarily work with 3D graphics professionally, but because of the timeline of this project, I decided to do 2D illustration and use really simple like CSS-based animation, so I could do it quickly. Slide, please. So first, the design. I really wanted to emulate the look of the subway system, like the design language you see at a station. So I created tileable materials like the hazard strip at the top and the tile background and the blue painted plywood that you see in construction areas. And then I used CSS to try to really faithfully recreate the signage for my information panels. If you go to the website itself and just scroll down a little bit, I'll just show you, if you go down to the tram section, I wanted to contextualize just a little further I wanted to contextualize each section, which is based around each mode of transit, with some illustrations and animation. So again, I did these illustrations and use CSS to just lay it out nicely. And CSS animation is really straightforward or simple, but it works well for transit because it basically just allows you to interpolate things between two in space. So good for that. And if you just go down a little more to the subway section, I'll just show you one more example of this. So again, CSS to lay out like a subway station with some simple illustration, and then the subway cars, which were the most involved graphic to create. Hopefully one will go by. Okay, yeah. Nice. Yeah, so again, CSS animation, and then we can go back to the okay, so I'm gonna move on to how I used the data that I used. I used the hourly data sets for the subway and the bus system for blue painted daily data set. With the hourly set, you can go to the next slide. The hourly data set, I wanted to look at what had happened during the most recent available week on the subway, on the left, for example. So you can see, like other presenters, I used Matplotlib with Python to get the data from the API and then Python to add up all the ridership from each station and present this graphic. And I noticed as I was doing this that it was kind of difficult to line up when these big events, these big spikes in ridership, which correspond with like 9 a.m. and 5 p.m. on work days, they were kind of hard to line up with the timeline across the bottom. So I mess around with Matplotlib and create kind of heat map coloration that makes it a little easier to tell where those events are taking place. Okay, next slide, please. I also wanted to look at something raw ridership numbers. I wanted to compare things like stations or bus routes by popularity. The graphic on the left is bus routes, the top 15 this particular week of ridership. You can see the whole list of every available route or station on the site. And then a few similar things for a year. So things like average ridership for the entire previous year by day of week on the right there. Okay, next please. Okay, and then finally I'm going to talk about how I used the API to keep this data fresh. Since it's lately on the MTA, I wanted to make sure it was showing you only what was most recently available from these data sets. And as I was doing this, I realized that the API requests I wanted to have happen were just the volume was too high to do the way that I initially wanted to. So I set up a simple web app that would take care of those 5 p.m. on work days. So if you're like me and you haven't worked with data API like this much before, I found this intimidating at first, but I just wanted to quickly, how this API request for the tram ridership, for example, is happening, because I found it was actually pretty straightforward and fun to work with once I got the hang of it. So essentially here, you just have, this is one URL for the API request that's broken down into each section. So I have the address of the API endpoint at the top. This is coming from the subway hourly data set, which also includes the tram, which is nice. You have your API token unique to your app, and then you can start to filter it by parameters like transit mode. So here we're only returning the tram data. We're limiting it to data between the date week start and date most recent, which are just timestamps that are formatted earlier in the Python script. And then sorting it in descending order so we know we have it in a useful order. And that plugs into Matplotlib, and basically just you get that graphic on the right. Okay, next please. So finally, as I was doing this, I was initially thinking I could do something like have your browser, when you visit this website, connect to the API endpoint and make all these requests so that you would know 100% this is the most recent data possible. But I pretty quickly realized that was untenable, just because of the scale, the volume of API requests I wanted to do to get all this data. So what I found as a workaround was I found this great website called Python Anywhere, where you can upload a Python script like the one I'm using for this. And you can set it to run, say, once a day, which is what my script is doing. And as the script runs, it does all those API requests. There's no need for it to be particularly fast, which is great, since we're not like visiting the website and then expecting it to populate immediately. So that script runs, it formulates all the data into the JSON you see on the left, which is what lately on the MTA uses accesses for the data on the site. And then it also uses that matplotlib to spit out all the graphics on the right. So when you visit lately on the MTA, this is everything that is returned by that web app, and it should be about a 1 day late at most, and well optimized for the API. Okay, last fix. Okay, thank you. This is my website and my email. I think making sure we tell accessible and interesting stories with this kind of data is more important than ever. And if you want to reach out about a project or anything else, please do. Thank you.
Hi, everybody. So I made If You Give a Rat a MetroCard for the MTA's Open Data Challenge. I had a lot of fun making this, and I'm very happy that the MTA also had fun reading it. You can read it on the QR code. Don't rush to scan it. I'll flash it in at the end. But mainly it's just a little digital zine that presents some like subway ridership data and connects some weather data to it, just to in like a fun kind of engaging way. This isn't going to be a live reading, but I am going to talk about the process and why this exists. Next slide, please. But yeah, so it may not seem like it, but this did take a surprising amount of analysis to make. On the GitHub, there's a link on the page the QR code points to onto a GitHub repo that has a mess of Jupyter notebooks that, if you're curious, you can go through. But it became this mess mainly because when I started working on this, I had no idea what I was doing or what I was really looking for. I just knew I was interested in the ridership data set, and I wanted to do something with that. But I knew that if I wanted to find something in it, I had to start small. So next slide, please. And I did. So this is just the estimated ridership hourly. I think you've probably seen this slide through these plots before. But it's super basic, super simple. It's just plotting weekdays and weekends hourly ridership across all stations. But it was just enough to get started. It offered me a good baseline to kind of reference when I, apply different variables to it, just to see how those spikes changed or how ridership differed. It just allowed me to ask interesting questions like, how does rain affect rush hours at all, or how do sporting events affect weekdays, or what does Friday night ridership look like? It was just a great sort of jumping off point and a great way to kind of go and take a rabbit hole like this. Next slide. Like other questions, and like on beach days too, like hot summer days. One question I had, and one thing I looked at was, what did ridership look like on hot summer days when people went to the beach, like in neighborhoods with beach neighborhoods? And there was an interesting pattern I found, like on weekends, ridership always peaked after the max temperature was reached on that day, post like weekdays. Why it is, I don't know, but it was an interesting kind of observation I found. Next slide. And what did ridership look like on Friday nights and weekend nights, especially during like rainy days? Like, we all kind of know that we like to stay in, but it was really interesting to see that kind of quantified in the data. And you can see that kind of just obviously dips. And then ridership dips by like 33% during rainy days, like during those summer thunderstorms or cold rainy nights, which is really interesting. Next slide, please. So I had all these little snippets and kind of a mess of plots and data that I really still had no idea how to put them all together. I knew I wanted to tell a story. I didn't know what it was yet. So there's always a very common trope, next slide please, of telling a story through data. And I thought it would just be easiest to write an actual story. And so I pretty much was trying to figure out what my narrative was going to be, what my main character was going to be. And so with the deadline very fast approaching, I quickly decided on, next slide please, my partner's rat was going to be the main character. This is Rosemary. She is the cutest thing in the world. And my, next slide please, my use for this project. She was so perfect. She'd only been on the subway twice. But regardless, she made the perfect main character. So yeah, I had my muse, my analysis, my makings of a narrative. I just need my illustrations. So next slide, please. And I started out similar to my analysis. They were just sort of like separate things that had no idea what they were going to be yet, but they all looked kind of interesting, but and then put together. Next slide, please. They all kind of create this nice cohesive scenes of New York, which looked really nice to me. Next slide, please. And then you could keep going. They all just sort of came together. This is hot and bothered rat, yep. And then next slide, please. And then yeah, that's our long day home. A rat comes up to you on the subway. I don't know if that's ever happened to you guys. But yeah, in the end, I had a very beautiful, next slide, please. Little zine, a little cute story that I'm very happy that I got to make and share with all of you. Thank you very much. Hi, everybody. My name is Marc Zitelli, and I am one of the contributors on the Subway Stories project. Unfortunately, my collaborators couldn't be here today, but I am going to do my best to share our project. So yeah, we were super proud of our entry, which was honored as the most creative storytelling in this, although I think Will might have given me a run for my money. So as I'll show you soon, our project pairs a beautiful interactive map showing where people are coming from and going to on the subway, as well as 5 journalistic stories that follow different communities as they move throughout the city. Now, before I get into the project, I want to start off by making a point about the power of narrative. Next slide, please. What you see on the screen are a handful of tweets I gathered while putting together this talk. Prominent political figures and everyday people alike are all weighing in on a hot button issue. Is crime out of control in New York City and on the subway? Now, I am not here to talk about politics or answer this question directly, although I'm sure a lot of us have some pretty strong feelings about this. But you can see that people are bitterly divided about the truth of the matter. And with all this noise, can you really blame people for not knowing what to believe, especially people from out of town? Crime in particular is a tricky concept because it refers not just to 1 or 2 or 3 events, but a whole constellation of events that occur at a scale way too large for any one person to really comprehend. One of the most powerful tools we have for understanding these sort of large-scale phenomenon is data analytics, and it's a necessary tool. The scientific method tells us that while it may be tempting to take our individual experiences on the street, positive or negative, and extrapolate them to a city of 8.5 million people, we should resist the urge to do this because somebody else might have a different experience and do the same thing, and now you have strangers arguing on the internet, claiming they're being gaslit, and this is exactly what we're seeing today. Excellent. Because unfortunately, we don't feel data. Data analysis is a relatively new phenomenon. It can be kind of confusing to understand, even make some people's eyes glaze over. But the human tradition of storytelling, on the other hand, dates back over 30,000 years and resonates with us on a much more immediate and personal and intimate level. So while data might be the best way to actually get the truth about what's going on, narrative is way more effective at swaying people's perceptions and opinions about a particular issue. And narratives can really say anything. Obviously, we see a lot of stories in the news about crime running rampant because these are the kind of stories that make us feel angry and fearful so that we click on them. But there's also a lot of stories about how New York City is safe, even if they're less exciting. For example, and this is a true story, one day my friend was hanging out on the benches at Union Square with his backpack hanging over the back. In a moment of absent-mindedness, he just got up and walked away and left his bag. 30 minutes later, he comes sprinting back, freaked out. Lo and behold, his backpack is still there in the same spot with his laptop and everything else inside untouched. So from this story, we can say that crime is way down, everything's safe, and what he did is a good idea, right? Of course not. But it serves as a cautionary tale to avoid generalizing personal experiences to make broad, sweeping statements about a city of 8.5 million people. Crime is just one hot topic, but New York City is filled with narratives, and data can tell us about every one of them. With that lesson in mind, we created Subway Stories as an experiment in combining the powerful data sets made available by the NTA's open data team with the compelling narratives that surround us living in a city like New York. The dataset we use in our project is the origin destination ridership dataset. This unique dataset uses the 2 most recent swipes from a single MetroCard or OmniID to estimate a trip in the subway. For example, if a rider swipes into the system at 8 a.m. at Times Square and swipes back into the system again at 5 p.m. at Fulton Street with no swipes in between, it's likely this person was commuting to work from Midtown to the financial district. This would get visualized as outgoing traffic from Times Square to Fulton Street at 8 a.m. on that day. Now, of course, these numbers aren't perfect. It's an estimate. People may make multiple stops throughout the day. They may walk to a different station nearby or take a bike or a bus. We didn't have time to integrate bus data, but we would love to do that eventually. But it gives us a really solid estimate about the large-scale movements of New Yorkers throughout the subway system every day. So without further ado, let's dive into the project. When we were developing this project, we felt it important to include both a story mode where we highlight specific trends we found in the data that were supported by the data, as well as an explore mode, which is kind of like a free play mode where you can pick a station, line, date, time, month, and just play around and maybe even look for your own trends in the data. When we found trends that were strongly supported by evidence, we included them in a story mode so they could be enjoyed and hopefully learn from by everybody. So I'm going to share a few of those stories now, and bear with me because I'm going to go over here. So a great example of this kind of storytelling can be seen in our Tale of 5 Chinatown story, which I'm sharing with you now. When we were first analyzing the data, we noticed an abnormally large amount of people commuting from Bensonhurst in Brooklyn down here to Grand Street in Manhattan pretty early in the morning on the weekend. We weren't really sure what was causing this, but after doing some research and talking to a few of our friends that lived in Bensonhurst, we learned that a lot of young Chinese New Yorkers go travel to visit older family members and enjoy like a dim sum breakfast meal with those family members. So what you're seeing here is incoming traffic on the Grand Street BD line right in the heart of Chinatown at 8 a.m. on Saturday morning. That's a pretty solidly large amount of people making that trip. And what you can see down here are the various, stops and stations and people making that trip from different parts of Bensonhurst, even Sunset Park, and different areas of Brooklyn. It's pretty cool to see a story like this that has a relatively small scale when compared, to a system that has an average of 4.5 or 4 million riders every day. But this is still clearly visible in the data. And this is why we wanted to create the story mode so we could highlight these kind of stories, no matter how small or large, so that everybody can enjoy and learn from them. And speaking of large stories, the next story I'm going to share is massive. And while it may be pretty apparent to most of us, I still think it's one of the most interesting stories, and it's the story of how New York City works. This story highlights both out-of-city commuters as well as local commuters and draws interesting comparisons between where they come from and where they go to work. The story starts by looking at the large influx of traffic coming into the city through massive gateways, commuter gateways like Penn Station, Port Authority, and Grand Central Station, but also illustrates locals commuting to many of the same business districts. If we look at incoming traffic at Grand Central, Times Square, and Penn Station, Port Authority, we can see the truly massive numbers of people coming in. And this is just at 8 a.m. This is just 1 hour. There's almost over 20,000 people coming into the city to commute. And this is honestly probably an underestimate. It's also really interesting to see where these people are going to work once they're in the system. So if you look at departures from Port Authority and Times Square, we can see a lot of people going to these business districts in Midtown East, as well as Spidey, and even a little bit in downtown Brooklyn. if we examine some of the stations in Midtown East more closely, like this Lexington Avenue 51st, 53rd Street station, we can see a nice mix of both out-of-city commuters coming from some of these places we just looked at, as well as more local commuters coming from Uptown, Upper East Side, Yorkville, parts of Queens, and even a little bit from Lower Manhattan and downtown Brooklyn. While we did spend a lot of time finding stories for this project, we're sure there's still many more yet to be discovered, which is why we included that Explore mode that I'll demonstrate now. So this mode, you can toggle between all the days of the week, times of the day, arrivals at or departing from, and you can pick, we have an all stations mode, which is kind of self-explanatory. You can see all the stations, or you can pick any station and kind of just play around and look for interesting trends. One thing that I think is cool, if you go to the all stations mode and kind of toggle through the hours, you can kind of see like this cool heartbeat effect of like the two commuter spikes. I think that's a really cool effect that you can see on the map here. Ultimately, data tells human stories, and we made this project with the hope that users can learn about communities that they may not personally be a part of, and in doing so, we can all understand each other just a little bit more. With that, I hope you learned something interesting here today, and thank you for your time and attention.
Can we get one more round of applause for all? Okay, I was so anxious about us running over time, and now we have 10 minutes. Do you guys want to do some questions? Do people have questions? Do people want to just go eat lunch? I think lunch is next.
Can you maybe talk a little bit more? Oh, sorry.
Oh, sorry. Go ahead.
What? Oh. I had a question about the first group's presentation. So, amazing presentation. I work in like, I do all the like voter behaviors and elections, and like a lot of the work that we kind of having gaps with in finding with data in terms of data is like voters with disabilities. Like, can you give me a rundown of like what?
I'm not sure if the data set, you guys specify what the data set was. I might have missed it. Could you clarify to me a bit more about that data set, please?
Yeah, it feels the slide for it. Yeah, it was a demographic snapshot of DOE schools. So it was middle, elementary, and high schools. But yeah.
So I'll see this. So this was a data set provided upon a DOE.
Yeah, and it wasn't just disability rated, but that was part of the data set that we were looking at. It had number of students enrolled with disabilities, and then percentage of students enrolled with disabilities in each high school. Yeah.
Oh, I see it. The deep low.
Other question 6.
So there's a comment. So I'm not going to masquerade it as a question. I've read a lot of analysis criticizing the LIR's mapping of routes, and the criticism uses the sort of analysis that you've used of where riders are getting into the subway system. And a lot of these come from a 40-year plan, and people are going to go to work. And an example is you notice like a really important part of New York City is the like Midtown East. So along on the LIR from Jamaica to that area, if you go through Atlantic and take a train, there's a small penalty for time, but it's not well balanced. So this is a really cool analysis and part of a larger complex.
Thank you, Jediah. It's an interesting point.
Other questions or comments? Oh, finger pointing. Sorry, thank you.
Can you tell us a little bit about the NCAA challenge itself?
Oh, yeah. Great question. So, yeah, we ran the MTA Open Data Challenge last fall. Hannah and I organized. We just really wanted to put out a call to adults in the community to use MTA data and build something cool. I think we've reached a point in the program now where we have over 160 data sets published, and we just wanted to raise awareness of our program and the data that the MTA makes available. And we were overwhelmed, I think, by the response to the challenge for sure. So hopefully we'll run it again sometime. But it does take a lot of time internally to do that. So we'll see when we do it next.
Annuals, right?
Not what?
Not annually. Every year?
TBD. No, I'm not going to commit to that. Okay. Thank you all so much for coming.